Welcome back to Series on Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to the channel for future videos and notifications. Alright, so in this video we're going to cover a very simple series test, and it's called the P-series test. And not only is this a simple test, it's very useful for other tests and proving whether or not series are convergent or divergent. In fact, just as in the case of the harmonic series, which we covered in the previous video, we're actually going to use the P-series test a lot in the direct comparison test, which we'll cover in some videos from now. Okay? Now, what is a P-series? Okay, a P-series is when you have a series in some form like this. Alright, so we've got a series from n equals 1 to infinity. And this number doesn't have to be 1, it can be any number. You know, it can be 3, negative 10, whatever. But in the denominator, you have n raised to some power p. And the result of this test depends on whether or not p is greater than 1 or less than 1. Okay? So let's look at some examples of series that would be a P-series test. Alright, so here's one series from n equals 1 to infinity of 3 over n squared. That's a P-series test. In this case, we've got a 3 on top. That doesn't matter. It just has to have some constant on top. But in the bottom, we've got n squared. So P in this case is 2. Okay, P is 2. So we would ask ourselves, is P greater than 1 or is it less than equal to 1? Well, P is 2, so it's greater than 1. So this first series actually would converge. Okay? Now, we haven't really got much into series yet, but most of these tests, except for the geometric series, most of these tests, they only tell us whether or not the series converges or diverges. It does not tell us if it converges what it converges to. Okay, it only tells us if it converges. So the most we know about this series is it converges. Okay? Let's look at the next series. From n equals 1 to infinity of negative 10, again, this doesn't matter up here, divided by n to the 1/4 power. All right? So the question is, does this series converge or diverge? Well, what's our p? Because it looks like a P-series test, our p would be 1/4. A 1/4 is less than 1. So this second series would actually diverge. Okay? It would diverge. And so this would not be a useful series if we were trying to do it for something, use it for something. Okay? Let's look at this third series down here at the bottom. This doesn't look explicitly like a P-series, but because we've got a root in the denominator, a radical notation, but if we look at it, n equals 1 to infinity of 1 over square root of n, we can rewrite the square root of n as n to the 1/2 power. And now I've put it explicitly in a form that looks like a P-series test. So what's our p? Our p is 1/2. And 1/2 is clearly less than 1, and so the series diverges. Alright, let's look at the series on the right here. I've got the series from n equals 1 to infinity of 1 over n to the pi power. Okay, so obviously I don't have a traditional Arabic number here. I've got this Greek pi here, but it's still a number. And it looks like a P-series test. I've got n raised to a power. So pi. How does pi relate to 1? Well, it's 3.14, so on and so forth. That's greater than 1. So therefore, because p is greater than 1, this series converges. Okay, so this would be a useful series to use for whatever purpose. Okay? Now, the question is, what happens if let's look at this right here. Let's say our p is 1. So 1 over n to the first. What happens there? Well, 1 over n to the first is just 1 over n, right? And we say our p would be 1. Remember, this is p is less than or equal to 1. So we'd say the series diverges. Well, what's 1 over n? Or at least the series from 1 to infinity of 1 over n. Well, we just covered that in the previous video. 1 over n is the harmonic series, which we already showed diverges. So that's why when you look at this P-series convergence, that p greater than 1 it converges, but less than or equal to 1 it diverges. In fact, the harmonic series is actually just a special case of a P-series. It is a P-series because n is raised to the first power. It's still a number, it's still a p, but because it's equal to 1, that harmonic series diverges. Okay? So P-series tests are really important to be able to recognize. You just usually have some number over n raised to some power. Okay? And you pretty much just need to know is p greater than 1 or less than or equal to 1. And then that tells you whether it converges or diverges respectively. We're going to be using p-series extensively, especially when we do the direct comparison test later on in this playlist. That's one test where we're going to be using this quite a bit. Okay, so hopefully this makes sense, the p-series convergence. And after this, we're going to do the geometric series. And then after that, we're going to go into some more complicated series tests, the ones that everybody fear. So stay with us, join us for those videos. Make sure to like this video and subscribe to the channel for future videos and notifications. Thank you.